Good morning, everyone. Let me introduce myself. I am Laaiba Shaikh from Batch 4, presenting, presenting the topic atomic structure. So, the topics we'll study today. The topics we'll study today are Introduction to Atomic Structure, Historical Development of Atomic Theory, Atomic Number and Mass Number, Isotopes and Isobars, Nuclear Reaction and Radioactivity. So, let's begin with the info of atom. Atom is a particle comprising a nucleus at center and containing positively charged particles called protons, neutral particles called neutrons, and a negatively charged particle called electron that revolve around the nucleus. Next is the historical development of atomic theory. Dalton was the first scientist to propose atomic theory. He said that atoms can't be further divided into subatomic parts. Therefore, the main drawback of Dalton's theory was that atom can be divided into subatomic particles that are electron, proton, and neutrons. Electrons are a subatomic particle that contain 1 unit negative charge of 1.6021 into 10 to the power minus 19 coulomb. Mass of electron is 9.108 into 10 to the power minus 28. Discovery of electron was done by discharge tube experiment. It showed the emission of certain invisible rays from the cathode which produced fluorescence on the glass and affected a photographic plate. These are called cathode rays. Next is proton. Protons are subatomic particles which bears a positive charge of 1.672 into 10 to the power minus 24 coulomb. Mass of proton is 1.672 into 10 to the power minus 24 gram. Discovery of proton was done in 1886 by E. Goldstein. He discovered an entirely different type of rays in the discharge tube. He observed that if a perforated disc cathode is used by J.J. Thomson and the gas pressure was not too low, then the colored ray emerged on the opposite side of the arrow. These rays travel in the form of stream canal and produced a goal on the other end of discharge tube. Goldstein called them canal rays or laser rays. Later, these rays were found to be consisting rays of negatively charged particle. Next is plum pudding model given by J.J. Thomson in 1897. According to Thomson, an atom is a sphere of a charge in which electrons are embedded as shown in the diagram. But it failed to experiment the subsequent experiment done on the atom and concentration derived from them. Next is Rutherfords alpha scattering experiment. Rutherfords alpha scattering experiment was done in 1911. E. Rutherford, H. Geiger, and E. Marsden performed a historical alpha particle scattering experiment which provided remarkable information regarding the arrangement of constituent particle in the atom. Atomic number and mass number. Atomic number was described by Henry Moseley. It is the number of protons present in the nucleus of an atom of an element. It is denoted by Z. Z is equals to number of proton is equals to number of electron. Mass number is described by Rutherford and Chadwick. It is the sum of total number of proton and neutrons present in nucleus of atom of an element. It is denoted by A. Mass number is equals to number of proton plus number of neutron, which is also equal to nucleons. Isotopes. Isotopes are elements having same atomic number but different mass number. Isobars are elements having different atomic number and same mass number. Isotones are elements having same number of neutrons. Now comes nuclear reaction, which involves fission and fusion. Fission and fusion are the nuclear reaction involving the breaking or joining of atomic nuclei. Next is radioactivity. Radioactivity is a nuclear phenomena. The nuclei of all radioactive substances are constant, and in order to acquire stability, they disintegrate.